Good afternoon. In today's class session, we are going to be discuss about sliding window protocol, the concept that is used in data link layer. It is a technique for used for sending a multiple frames at a time. It is used the concept of TCP/IP protocol. You know that TCP/IP is a connection-oriented protocol, reliable and a guarantee protocol. Whatever the frames that we are going to be sent from one end to other end, that must be received without any damage or lost, okay, or corrupted, right? So that's the point is very clear is the purpose of the sliding window technique is used to avoid the duplicate data. In the case of sliding window protocol, we are used to two type of the protocol. One is go back in ARQ. ARQ means automatic repeat request, and second one is selective repeat ARQ, right? So go back NRQ is something, but it is also known as go back in ARQ protocols. N means that is window size that is set by the system, right? So N may be a 3 or 5 or 8, right? So at the time you can send 3 frames from sender to the receiver, or 8 frames from sender to the receiver, or 5 frames from sender to the receiver. So N is the window size that's set by the system. So in this case, what is the responsibility of the data link layer? Accept the packet from the upper layer, that is the network layer. The data link layer responsibility to convert it into the frames and send the frames, all the frames to the receiver, right? So all the frames to the receiver. So in this case, if any frame is corrupted or lost or damaged, the responsibility of the center to send subsequent frames, from the center to the receiver. Suppose I am going to be send 5 frames from the center to the receiver. The second frame acknowledgement that is sent by the receiver may be lost or damaged or may be corrupted. The center responsibility to resend all the subsequent frames 2, 3, 4, 5. So all the center responsibility to send all the subsequent frames from sender to the receiver, right? So that is the point. This all okay, and also the responsibility of here there is a concept is used as a timer. Okay, the center responsibility if the receiver does not receive the frames within the fixed time that is set by the center responsibility to resend the frames. So when the timer expires, the center responsibility to resend the frame. Okay, so go back NRQ, the concept is explained with the help of the diagram. You see this, the window size is 3. I am going to be sent 3 frames, 0, 1, 2, 0, 1, 2, 3 frames from center computer to the receiver computer. The receiver computer receives the first frame and send the acknowledgement to the center. After receiving the acknowledgement, the center send the next frame, that is you see the diagram, okay, the center sends the frame 3 to the receiver. The receiver receives the frame, and send the acknowledgement the second frame and send the acknowledgement to the second frame. While sending the acknowledgement from the receiver to the center, the second frame, the frame may be corrupted or lost or damaged. Maybe there is some external or internal interruption in the network. Maybe corrupt or damaged or lost in that. The center responsibility to send all the subsequent frame from the center to the receiver. You see the diagram now. So that is all the subsequent frames 2, 3, 4. I am going to be resending. The center responsibility to resend the frame 2, 3, 4 to the receiver, all the subsequent frames, right? This is the one technique we can say as a go back in ARQ. In the second case, selective repeat ARQ. So what is the drawback of the previous method is, in the previous method now, if one frame acknowledgement is lost, the center responsibility to send all the subsequent frames. So that will be takes much time, and also the memory is also the considerations. Okay, so one of the drawback is we are going to be all the subsequent frames are again be sent. That is the time consuming, right? So and also memory also we are going to be considered in the case of the network traffic, right? In the case of selective ARQ, that is we can send instead of multiple frames, that is okay, so multiple frames before receiving the acknowledgement for the first frame, right? So we are going to be send multiple frames from the source computer to the destination computer, right? In the case which frame may be damaged or lost or corrupt, that frame must only that frame is sent by the receiver instead of all the subsequent frames. You see this diagram, right? The sender sends a frame 0 and 1 to the receiver. The receiver receives the acknowledgement ACK 0 and ACK 1. In the second frame, right, in the second diagram, you see that the sender sent frame 0 and frame 1. Sender also receives ACK 0 and ACK 1, right? And you see that in the case the sender sends frame, okay, the second frame, right, from the sender to the receiver, and suppose they may be corrupted or lost or damaged, right? The sender is sending the only the right that frame only, the second frame only that is sent by, not by all the frames, right? This is the concept. So go back in the NRQ the concept. If one frame that is the acknowledgement is sent by the one frame is lost or damaged or corrupted, the sender responsibility to all the subsequent frames is sent. In the case of selective ARQ, okay, the sender responsibility to send the multiple frames, right? And while receiving the frames, which frame acknowledgement is now, that frame only sent, right? Not all the frames. Thank you.